Hello guys, in today's lesson we're going to talk about the exponential and logarithmic functions, and let's start by the exponential functions. So this is how we show the exponential function. The function of f of x is equal to the a with the power of x, and there is a condition. There are some conditions here. First off is that a should be greater than 0, not equal to, it should be greater than that. And a should then be 1. So we call the a here, we call this base, and we call the x exponent. And let's say if x is equal to n, and n is a positive integer, then for example a with the power of n is equal to a times a times a times a to infinity, to n, and the number of n's is the n factor, so the number if we multiply a by a is n times. So now let's go by exponential and power functions. So I want you to tell you guys what is the difference between the exponential function and a power function. So here, for example, x with a power of 2 is a power function. So as x approaches the infinity, y also positive infinity or negative infinity, the y also approaches infinity. Also y approaches to positive. So here, just because this one is with a power of 2, we the y all just approaches in positive infinity. But the exponential function is quite different. It's, for example, 2 with the power of x. And it says as x approaches the infinity, y also approaches infinity, and it grows rapidly in comparison to the power functions. So, and as x approaches to negative infinity, y approaches to 0. And if we want to show it in a diagram, this is how I show it. So first off, let's say that's okay, that's our function. So first, let's show the x with a power of 2. As you know, it would be something like that. This is y equal to x with a power of 2. Now, let's show the power function in a way, something like that. Okay, we all know any number with a power of 0 would be 1. So, let's call here 1. In our functions, it's going to move that 1, like it's moved from this point. So our function, and as we said, as x approaches negative infinity, y approaches 0. So we start from here, it goes up, then oh my god, why is it like that? Now let's try it again. Okay, it goes up, and then after some it grows more rapidly in comparison to the power function. But if we like, the basic form of it would be y is equal, and as we said, a with the power of x, where the domain is negative infinity to positive infinity, and the range, as we said, when it approaches the negative infinity, it goes to the 0, but it will never hit the 0, so in positive infinity. It's asymptotic to the x-axis, so but let's call it that. So what is a natural exponential function? So the natural exponential function is a special case of exponential function with a base e, which is equal to 2 point, so let's just 2.817, I guess, something. And in some problems it would, and in some cases it's going to help us a lot. And and this is how we should. So like just like before, f of x is equal to the e to the power of x, and e is a base of 2.8 something. But if you want to show you a general formula for exponential functions, it would be like this: y is equal to ma with the power of bx plus t. If you want to draw the graphs of these, this is how we should do it. Okay, sorry guys. So, let's just, okay. For example, this is start just by the example that I just said. This one is y is equal to with the power of x. Now, let's multiply it by something, for example, 5. So now, the functions, the graph of it would be a bit different. So it's going to have a higher slope here. You see that one in comparison to this one. So for example, we call this y is equal to 5 times 2 with the power of x. So now let's draw another one because we don't have any much space here. Okay. And now, let's say we have the function of 2x, but let's say 2 with the power of 2x. This one also will have a higher slope in comparison to the y with the power of 2x. So let's just, okay, this one is, for example, y is equal to with the power of x. And so since this one is going to have a, sorry, it's not going to have a much difference, but after that there's going to be a significant difference between them. So this one is a 2 with a 2x, 2 with the power of 2 with the power 2 with the power of 2x instead of x. And okay, now let's add something to it. So for example, this one also again goes up, but here suddenly this one will have a higher thing. And for example, y is equal to 2x plus 2. And that's how we show them. If we happen to multiply it by a negative number, for example, -2, our function would look like this. It's going to flip around the x-axis. So for example, this one is -2 times 2 with the power of x. And that's how we show it. Okay, now there are some general rules in the fractional, so we call it wholes, like laws of exponents. And they're applicable if a is greater than 0, b is greater than 0, and x and y are real numbers. So these are the rules. A times x multiply by a times y is equal to the a with the power of x plus y. Again, a times x divided by a times y is equal to the a with the power of x minus 1. And now, a with the power of x multiplied by power of y. And this one will be a with the power of x times y. What about this one? A times b with the power of x. You can separate them. And this one will be a times x times b times multiplied by b with the power of x. And again, if it's like this, a divided by b with the power of x, this one will be a with the power of x over b with the power of x. Yeah, that's it. Now let's go for logarithm functions. So if the base, as we said, so for example, let's go down there, okay, no mind. As we said before, if the base is equal to a is greater than 0 and a is not 1, it's not equal to 1, and y is equal to a with the power of x. The logarithm form of this one would be x is equal to log a y. So this is the logarithm number and this is the base. So for example, how do we show it? So like just like here, y is equal, for example, 5 with the power of x. So what is the logarithm form of this? So this one will be log of, we set the base here, a is the base, so we write 5 down here, and this is the logarithm number, and we draw it like this. I'm sorry, y, and this is the logarithm number, which is equal to x. And as there's a thing to it, and we can say 5 with the power of x is equal to y, and that's how we show it. Like another example for this would be, for example, and it just comes from this one, 5 with the power of 2 is equal to 25. And how should we show it in a logarithmic form? This one, we said this is the power, right? This is the x. 2 is equal to the log of 5. This is the base, our base, and this is a logarithmic number, 25. And we can prove it, which I will show you later on in the video. So log of 5 is equal to the 5 with the power of 2. 25 is 5 with the power of 2. The power goes behind the log, so this one will be log of 5. If you have the same logarithmic number in the base, this one will be equal to 1. 2 times 1 is equal to 2, and we show it right here. And yeah, okay, now let's go to the properties of logarithmic functions. First, if log a equal, this one, sorry, I couldn't say it. So what this one says is a with the power of 0 is equal to 1. See, a with the power of 0 is equal to 1. Our base is a, our logarithmic number is 1, and our where did I show it? Okay, and so this is our y, this is our x. I'm sorry, this is our here. This is our x, this is our base, and this is our y, which will show it right there. Another rule is log of a, b, c. So we can separate this to the log a, b plus log c, a. And this is called the product property. What about this one? This one says log a and b divided by c. Again, we can just separate them, but this time, instead of writing plus, we'll write minus. We substitute them. This one is called quotient property. Now here, what if it's like log a b with the power of x? And if you remember here, when we said log 5 to the power of 2, I put the 2 behind the log, so it was log 5. And that's what it says here. This one will be x log a b. This one is called power property. Okay, now again here, what if it's log a with the power, and the logarithmic number is a with the power of x? Again, this one will be x log a. But here the difference is a and a will cancel each other out, and this one will be x times 1, which is equal to x. And yep, that's pretty much the rules here. Have a nice day. I mean, I can give you some examples if you want. Okay, let's do some examples. For example, it says, let's say, log with a base 2 at minus log 2 with a base 2 5. So we use the rule, what is called quotient property. So we write it as log 8t over 5 with a base 2. And this one will be log 16 base 2. What is 16 if you want to write it down as base 2 to simplify it? Look, 16 is a 2 with a power of 4, and this one is 2. So as we state before, 4 goes behind the logarithm. So it would be 4 log 2, 2. 2 will cancel each other out. This one is 1. So the answer of this question is 4. Simple as that. Okay, now let's do another example. Simplify the log of the base is 3. This one is 9 with the power of 2. Now we can do it in a simpler way, and that is, so we say 9 with the power of 2. We have a rule that was, so 9 is itself is 3 with the power of 2 with the power of 2. So this one is 3 with the power of 4. And so we can show like log of 3 over this one 3 with the power of 4. 4 goes that way, and this one is 4 log 3. This one cancel out, and this one is 4. Or we can, or we can show it like this. We can say the 9 has a power of 2. So the 2 goes behind the logarithm, so this one will be log 9 3. And then we again do it. This one is 3 with the power of 2. 2 goes out, and this one will be 4 log 3. So this one is 4. It doesn't matter how you should. I mean, you just have to decide which one is like easier to you. Another one is, another example will be log of 10, and yeah. So how should we show this to make it simple? This one is 10 with the power of negative 2. So our log is 10 with the power of negative 2 with a base 10. So this one goes out. This one negative 2 times log 10, 10. And this one will be equal to negative 2. And again, this is an important thing. When they just write it down like this and you can't see any base, the general thing is that this one is equal to 10. Like, you have to know it. And for example, this one here, log of 100, and they want you to calculate this one. You would say, okay, there's no base, but you should have known that when there is no base and there is nothing that is state that this one is our base, you should consider 10 as our base. So this one is basically log 10 with the power of 2, 10, and this one is equal to 2 because the 2 goes behind the log, and 10 with the 10 cancel each other's out, and this one is just 2. Okay, and